chilling units are necessary this year because we're in the third consecutive year of drought. The temperatures in Shasta Lake are very high, and we require extra cooling of that water before it enters the hatchery. The temperature control device on the upstream side of Shasta Dam in the past has provided adequate cooling. However, the temperature control device doesn't work when the lake levels are particularly low. When that happens, the cold water pool is depleted, and it limits the ability of the temperature control device to access the cold water pool in the lake. Back in April, we thought that if things didn't change, we could have exceptional water temperatures that we've never seen before coming into the hatchery. That's why we planned on 20 degrees of cooling, which is quite a bit more than we've ever had before. The chilling plant has been used for the Livingston Stonefish Hatchery twice before, once in 2015 and again last year in 2021. During those years, we required just 10 degrees of cooling. So the amount of machinery that we needed in those years was quite a bit less than we need today. The chiller system operates by taking intake water from Shasta Lake and sends it through a chiller plant. The main part of the chiller plant are heat exchangers. The intake water goes through the heat exchanger and it cools it down and then goes right back into the intake portion of the hatchery. On the other side of the chiller plant, on the other side of the heat exchanger, is a closed loop water system that brings water from the heat exchanger over to the chillers and then back to the heat exchanger again as cold water. So the performance requirement of the chilling plant is that it cool 20 degrees of temperature at 3,000 gallons per minute. We have temperature probes on the chilling plant that measure the temperature both inlet to the chilling plant and outlet, so we can test temperature performance that way. And then the hatchery has flow meters inside that can measure the actual flow going into the hatchery, so we can measure performance that way. We have 8 chilling units that are on site, and they are powered by 10 generating units. The chilling plant that we rented comes with 24/7 technician monitoring of the performance of the plant. And they go make rounds around the plant to measure for temperature and flow to make sure it's performing as needed. The on-site technicians are also able to troubleshoot and do light repairs to the chilling plant if necessary. If more than light repairs are needed, they will immediately call out more experienced technicians to troubleshoot and repair as necessary. As part of the chilling plant, we brought in additional capability. So we have additional diesel generators and additional chilling units in case the main plant goes down. We can swap in those additional units quickly and keep the plant up and operating. So this year we are renting the chilling plant. Next year we plan to purchase it for a permanent chilling plant. And we'll purchase enough chilling to give us the same amount of capacity, 2,500 tons, with some redundancy. At the same time, we're looking at bringing in more service power so that we don't rely so much on diesel generated power. And over time, our vision is that the entire plant will be operated on service electricity. We won't need any diesel generators at all.